Welcome back. This is Mr. Forbrick, and today we'll be looking at the 7th question from the 2018 exam. Now, to begin with, this is a short free response question. It's the 7th question, so it'll be worth 3 points. All right, and let's get into it. So to start us off, it says, in the tongue soulfish, sex is determined by a combination of genetics and environmental temperature. Genetically male fish have 2 Z chromosomes, and genetically female fish have 1 Z chromosome and 1 W chromosome. When fish are raised at 22 degrees Celsius, ZZ fish develop into phenotypic males, while ZW fish develop into phenotypic females. However, when fish are raised at 28 degrees Celsius, the Z chromosome is modified and noted as Z star. Z star W individuals develop as phenotypic males that are fertile and can pass the Z star chromosome to their offspring even when the offspring are raised at 22 degrees Celsius. A cross between a ZW female and a Z star Z male is shown in the Punnett square below. So we've got a scenario, we have fish, all right, we're given the genotypes of specific genders of this fish, and what's really unique is that it appears that the temperature at which they're raised can influence one of the alleles for that gender to transform from a Z to a Z star. Right? And ultimately what this may do is it could affect the phenotype of the fish itself. Instead of becoming female, we could have a Z star W and now a male fish. Now let's get into part A specifically and what part A is asking us to perform. So the task verb that I see right away is we're going to predict the percent of phenotypic males of the F1 offspring. And so this is a really straightforward one. I'm anticipating it's a single point. It just seems like a prediction. And the nice part about this is they've given us the Punnett square, so we really don't even have to carry out the cross. We just have to figure out who's male and who's female based on that data. Now, taking a look at this, I can see that anyone with ZZ, I'm going to put a little M for male. Those are easy. This is clearly a female, it's ZW. And the instance where we just saw that Z star W individual, we know that this is now, instead of being female, this will also be male. So that gives us 1, 2, 3 of our 4 offspring are going to be phenotypically male, and that leads to 75%. Now let's take a look at part B for this question. It says at least 1 Z or Z star chromosome is necessary for the survival of the fish. A researcher crossed 2 fish and observed a 2-to-1 ratio of males to females among the offspring. Based on the information, identify the genotype of the male parent in the cross, and describe one fitness cost to the female of mating with this particular parent. So I'm taking a look real quick. The very first point I'm anticipating is identifying the genotype of this male parent in the cross. The second point is going to come from describing a fitness cost to the female if I'm going to mate with this particular individual. Now, what strikes me as really unusual when I look at identifying the genotype of the parent is there's a 2-to-1 ratio of offspring that are produced. And so it says it right here. We have a 2-to-1 ratio of males to females. Now, typically in a cross, especially when each parent can pass along 2 different alleles, all right, we'd expect to see a 2-to-2, a 3-to-1 ratio. But 2-to-1, 2 plus 1 gives me 3, and that tells me that probably one of my offspring didn't survive. Now, if I use my context clues around this, it says that at least 1 Z or Z star chromosome is necessary for the survival of the fish. So it seems to me like one of my offspring probably inherited 2 W chromosomes, or I'm sorry, 2 W alleles. So let's take a look and work backwards to see if we can't figure out what that male parent's genotype looks like. So as we set up our Punnett square, we know that we have to have 1 male and 1 female, and the only female genotype that we know of is ZW. All right. Now, we also know that one of those offspring are not surviving, and so the only way to not survive is to have that WW genotype. So we can infer that the male also has to have a W allele as well. Now, knowing that to be male, we also have to have a Z allele. Now, ZW is going to lead to a phenotypic female. The only way we can have a ZW male is if that Z is really a Z star allele. So let's go ahead and figure this out. And let's find out who is male. So we have one male here. We have Z star W that's also male, and our ZW is our female. When we check it against our ratio, we get a 2-to-1 ratio of males to females. That looks good. So what that tells us is we can confidently now answer this question and cite that this Z star W is in fact the genotype of our male offspring or our male parent. Now the second part of the question asks, describe one fitness cost to the female. Well, looking at the Punnett square, for every 4 offspring I make, a quarter of them are going to die. And so the fitness cost in that the female is going to be less reproductively successful because fewer of her offspring are going to survive if she mates with a Z star W male as compared to a ZZ male. That takes care of this question. Thanks for stopping in. We'll see you next time.